you're working with large language models, you know you're always in a battle with two things, speed and cost. Well, today we're going to demystify a technique that hits both of those right where it counts, prompt caching. We're going to break down exactly how this thing works and how it can make your models way faster and, yes, cheaper.
I mean, who doesn't, right? It's pretty much the holy grail for anyone building with this tech. And believe it or not, prompt caching is one of the absolute best answers we have right now, because it's all about making your models work smarter, not just harder.
Okay, but first things first. We have to clear up a really common misunderstanding. See, when you hear the word caching, your brain probably jumps to one specific thing. But with LLMs, prompt caching, well, it's a completely different beast.
So on one hand, you've got what we normally think of, output caching. It's simple, right? Two people ask the exact same question, you just save the first answer and serve it up again. Easy. But that is not what we're talking about here. With prompt caching, we're not saving the answer at all. We're saving the heavy lifting the model does to just process the prompt way before it even thinks about giving you a response.
And this is the key takeaway, the one thing you really got to get. We are caching the input, not the output. It's not about storing the final answer. It's about storing all the computational work the model does just to understand what you asked in the first place. That difference is everything.
So, if we're not caching the output, what exactly are we caching? Let's pop the hood for a minute and see what's really going on inside the model during that initial processing phase.
The magic here all comes down to something called KV pairs, or key value pairs. You can think of this as the model's internal brain scan of your prompt. It's this super complex calculation where the model figures out how every single word relates to every other word, building this massive internal map of context and meaning.
And this all happens during what's called the pre-fill phase. So before the LLM generates even one word of its response, it has to chug through your entire prompt and create these KV pairs for every single token. Now, if you have a really long prompt, this is by far the most expensive, time-consuming part to the whole operation.
And there it is. That's the whole game. Prompt caching simply takes that huge, computationally expensive block of KV pairs and saves it. So the next time the model sees that same chunk of prompt, it doesn't have to do all that work again. It just grabs the result from the cache and is ready to go.
Okay, so we're caching these KV pairs, and that saves a ton of processing. This leads to the obvious next question. What kind of stuff should you actually be caching to get the biggest bang for your buck? And this is where it gets really practical. The perfect candidates for caching are those big, static chunks of text that you find yourself using over and over. The number one use case is the system prompt, the instructions that set the AI's personality and its rules. But it is an absolute game changer for feeding the model huge documents, like a 50-page user manual or a dense legal contract that you need to ask a bunch of questions about. Now, this brings up a really important reality check. This isn't for every single prompt. If you ask something short and sweet, the tiny bit of work it takes to even check the cache just isn't worth it. The massive savings kick in when you're dealing with prompts that have thousands of tokens, where that initial pre-fill phase is a serious performance killer.
All right, so we know what's a cache, but how do we actually set things up to make sure the system uses the cache? Turns out there are a few really simple but totally crucial rules you need to follow.
The core mechanism here is called prefix matching. It's pretty straightforward. The system looks at your new prompt and compares it to what's in the cache, starting right from the beginning, token by token by token. The very instant it hits a token that doesn't match, that's it. The cache stops, and the model starts processing normally from that point on.
So knowing about prefix matching is everything, because it means the order of your prompt is make or break. If you structure it wrong, you get absolutely no benefit from the cache. Let me show you what I mean.
So here is the golden rule. You put all of your static, reusable stuff first. That's your system prompt, your giant document, your few shot examples, all that stuff goes at the top. Then the unique part, the user's actual question, goes at the very end. That way, the prefix matching gets a perfect hit on that huge static block every single time. But now, watch what happens if you flip it around. If that unique user question comes first, the prefix is going to be different on every single call. The cache will fail on the very first token, and the model will have to reprocess that entire massive document every single time. You get zero savings. Structure is everything.
There's also a bit of a rule of thumb when it comes to size. Generally speaking, caching really starts to pay off when your prompts are at least 1024 tokens long. Any shorter than that, and the little bit of overhead for managing the cache can actually cancel out the savings.
And one last thing to keep in mind, these caches aren't permanent. They're designed to be temporary to keep things fresh. A lot of systems will clear them out after just 5 or 10 minutes, though some might keep them around for up to 24 hours. It's really built for a bunch of related queries in a single session.
Okay, so we've dug into the mechanics, the best practices, the whole shebang. What does this all actually add up to? Let's bring it all home and look at the real-world impact. You know, it really just boils down to 2 incredible benefits. First, your latency goes way down. By completely skipping that brutal prefill phase, you get the first token back from the model so much faster. And second, your costs plummet. You're billed for the tokens you process, right? Well, if you're caching a huge chunk of your prompt, you're only paying to process the new tiny part. It's a total win-win. So the big takeaway here is to start looking at your own applications. Are you sending the same big system prompt, the same document, the same set of examples over and over again? If you are, then structuring your prompts to take advantage of caching is probably one of the biggest and easiest performance wins you're going to find. So I'll leave you with this. What expensive prompt in your work could you be caching right now?